Have you ever wondered how we could reach Mars? This intriguing question has sparked the curiosity of many. The vast expanse of space, the millions of miles between us and the red planet, presents a formidable challenge. How can we possibly traverse such immense distances? How can we make a voyage that goes beyond our current capabilities? You might be thinking rockets or some advanced form of propulsion. Well, the answer might surprise you. It involves something you might not expect: nuclear propulsion. Nuclear propulsion. Now that's a term you might not hear every day. But what if I told you that it could be the key to unlocking the next frontier in space exploration? Let's break it down. Nuclear propulsion is a method of powering a vehicle. In this case, a spacecraft, using the energy released by nuclear reactions. In simple terms, it's like a high-powered steam engine, but instead of coal or gas, we're using the power of the atom. The process begins with a nuclear reactor, which houses a material that undergoes nuclear fission. When this material is hit with a neutron, it splits, releasing a massive amount of energy in the form of heat. This heat is then harnessed to heat a propellant, usually a gas like hydrogen, to extremely high temperatures. The hot gas is then expelled from the back of the spacecraft, pushing it forward. Now, what makes this so special? Well, consider this. The amount of energy you can get from a single pound of uranium, a common nuclear fuel, is roughly equivalent to burning 3 million pounds of coal. That's a lot of power in a small package. So, for space travel, nuclear propulsion offers two main advantages. First, it provides a much higher energy density than traditional chemical rockets. This means we can go farther and faster with less fuel. Second, unlike solar or ion propulsion, nuclear propulsion works just as well in the outer solar system, where sunlight is scarce. But it's not just about going faster. With nuclear propulsion, a spacecraft could carry more scientific equipment, support a larger crew, or even establish a permanent outpost on another planet. Of course, there are challenges. Nuclear propulsion requires handling radioactive materials, and there are significant technical hurdles to overcome. But the potential benefits for space exploration are enormous. So, nuclear propulsion could be our ticket to Mars, but how exactly would that work? Now, if you're still with us, you might be wondering how nuclear propulsion can propel us to Mars. Well, let's dive right into it. The mechanics of nuclear propulsion in space are quite fascinating. It all starts with the reactor core, where nuclear fission occurs. This is the process where atoms of certain heavy elements, such as uranium or plutonium, are split into smaller atoms, releasing a tremendous amount of energy in the process. This energy is not just any energy, it's heat energy. And in nuclear propulsion, it's used to heat up a working fluid, usually hydrogen. This heated, high-pressure gas is then expelled out of the back of the spacecraft, creating a force in the opposite direction. This force, or thrust, is what propels the spacecraft forward. This is Newton's third law in action. For every action, there's an equal and opposite reaction. Now, you might be thinking, but wait, doesn't a conventional rocket do the same thing? And you'd be right. The key difference here is efficiency. The measure of a rocket's efficiency is known as specific impulse. And nuclear propulsion systems have a much higher specific impulse than conventional chemical rockets. This means they can produce more thrust for a given amount of fuel. This is particularly important in space travel, where every ounce of weight matters. With a higher specific impulse, a nuclear-powered spacecraft could carry less fuel and more cargo, or travel further on the same amount of fuel. This is why nuclear propulsion could be a game-changer for missions to Mars and beyond. Now, this all might sound a bit complex, but try to think of it like a car. A nuclear propulsion system is like a highly efficient engine that can run for a long time on a small amount of fuel. The bigger the engine and the more efficient it is, the further and faster the car can go. Just like a car, though, a nuclear propulsion system needs to be designed and built properly to ensure it's safe and effective. This is one of the challenges facing scientists and engineers working on nuclear propulsion for space travel, but we'll get into that in a bit. Before we move on, if you're finding this information as intriguing as we do, don't forget to hit that subscribe button and give this video a like. It helps us continue to bring you fascinating content like this. So, as you can see, nuclear propulsion could potentially make travel to Mars a reality. But of course, like all great ventures, there are challenges to using nuclear propulsion for space travel. First off, let's talk about safety, a paramount concern when dealing with nuclear energy. Should a rocket with a nuclear reactor on board fail during launch, The reactor could end up anywhere, from the bottom of the ocean to our own backyards. The risks associated with nuclear fallout and contamination are real, and measures to prevent such instances are critical. Moreover, the technological hurdles cannot be overlooked. Designing a system that can withstand the immense heat generated by a nuclear reactor, while also being light enough for space travel, is no easy task. The reactor must also be robust enough to survive the violent vibrations of a rocket launch and the harsh conditions of space. So how do we tackle these challenges? For safety, robust containment strategies are necessary. The use of high-strength materials and redundant safety systems could help ensure that, even in the event of a launch failure, the nuclear reactor remains intact. As for the technological hurdles, innovation and advancements in materials science are key. The development of lightweight, heat-resistant materials could make the construction of a nuclear propulsion system more feasible. Additionally, advances in reactor design could lead to systems that are more compact and efficient, further reducing the weight and size constraints. Yet even with these solutions, the road to nuclear propulsion is not without its bumps. It requires significant investment, not just in terms of money, but also in terms of time and resources. It entails a willingness to push the boundaries of what we know and can do, and a commitment to continue learning and innovating. But why go through all this trouble? Because the potential rewards are immense. Imagine a world where Mars is not months but weeks away. A world where the depths of our solar system are within our reach. This is the promise of nuclear propulsion. Despite these challenges, the potential benefits of nuclear propulsion for space travel are enormous. So, can nuclear propulsion take us to Mars? The answer is, potentially, yes. We've come a long way in this journey of understanding nuclear propulsion. We've dived deep into the intriguing question, peered into the concept of nuclear propulsion, explored its mechanics in space travel, and faced the challenges head-on. And now, we stand at the threshold of a new era in space exploration. Let's take a quick recap. Nuclear propulsion, in its simplest form, uses the energy released by nuclear reactions to propel a spacecraft. This energy is exponentially greater than that provided by conventional chemical rockets. That's what makes it such an attractive option for long-distance space travel, such as a voyage to Mars. We drilled down into the mechanics of how nuclear propulsion could work in space travel. We learned about the two main types: nuclear thermal propulsion, which uses nuclear energy to heat a propellant and expel it to create thrust, and nuclear electric propulsion, which uses nuclear energy to generate electricity that then powers an electric propulsion system. Each has its own strengths and challenges, but both hold significant promise. We also face the challenges and potential solutions. Radiation risks, weight constraints, and the need for extensive testing and safety measures are all significant hurdles, but they are not insurmountable. With advances in technology and engineering, we're gradually overcoming these challenges. Shielding strategies are being developed to protect astronauts from radiation. Designs are being optimized to reduce weight, and rigorous testing protocols are being established to ensure safety. And that brings us to the future implications. If we can successfully implement nuclear propulsion, it could revolutionize space travel. It would not just make a manned mission to Mars feasible, but it could also open up the rest of the solar system for exploration. Imagine humans setting foot on the moons of Jupiter or Saturn, or sending probes to the farthest reaches of our solar system and beyond. The possibilities are truly endless, but let's not get too far ahead of ourselves. There's still a lot of work to be done, a lot of challenges to overcome, but the potential reward, a new era of space exploration, makes it all worthwhile. And who knows, someday, in the not-too-distant future, we might just see a spaceship powered by nuclear propulsion embarking on a journey to Mars. Thank you for watching. We hope you found this exploration of nuclear propulsion as fascinating as we did. See you in the next video.